Hello, we're going to look at one more example from chapter 6.4. Chapter 6.4, difference of means. So the server kept track of the tip percentage left on 157 different bills. And this is from a restaurant, First Crush, in northern New York. So the mean percentage of the tips left on 106 bills that were paid in cash, 16.39%, standard deviation of 5.05%. And then the mean percent of 51 bills paid with credit card was 17.10%, standard deviation of 2.47. So a slightly higher percentage that was paid on credit card than cash, but maybe that's just due to randomness. It's less than a 1% difference between those two. So let's see if there actually is a difference in general. There's a small difference on this one sample, two different types. So let's run a hypothesis test to check to see if there's a difference in the tip percentage. All right, so and here I list out all the steps. I'm going to give you these on the exam, so don't worry about memorizing them. State the null alternative hypothesis using proper notation. Describe what the population parameters represent. So 1 and 2, these could go in really either order. I'm actually going to write up, let's start over here. I'm going to describe the population parameters first. Let's say mu sub CR is going to be equal to average tip percentage left on bills paid by credit card at this restaurant, First Crush. And then we have a different population mean. Mu sub cash is going to equal to the average tip percentage left on bills paid by cash at First Crush. So I want to see a sentence or two just describing what the population parameters are. And now for the hypotheses. The null hypothesis are going to be that these two population means are equal to each other. And the alternative, we'll want to just check to see if there's a difference in the mean. So it's mu sub credit card is not equal to mu sub cash. All right, so that's stating the null alternative hypothesis and describing what they mean. So either order's fine, as long as you kind of both descriptions. All right, the sample statistics using proper notation. So here we have X bar sub CR for credit card. Credit card's left 16.39. S sub CR, that's the sample standard deviation, 5.05. X bar sub cash, the average for the cash sample was 17.10. And the standard deviation for cash is equal to 2.47. Oh, let me add here the sample sizes. We have two different sample sizes. The number of credit card bills were 106. And then over here for the cash group, and so cash, that was what, 51 bills paid in cash. So that's the sample statistics. Are conditions met to use Z or T distribution? I'm going to go into, this is the inferential statistics formulas for chapter 6. We're looking at a difference in means. So we need either sample sizes of at least 30, or both populations have to be assumed to be normally distributed. And then are we doing T versus Z? Right here. I like to think about, we're going to use T because we only know the sample data. We only know sample data, so we're going to use the T distribution. So we use T distribution because we only know sample data and requirements are met to use t-distribution since both sample sizes are at least 30. We've got 51 and 106. All right. State the test statistic and p-value. So I write the formula here. T is going to equal, in general, it's the statistic minus the null over the standard error. I don't know what that means in this case. And if I go to the formula sheet, right here, this third column is the test statistic. So it's the difference of the two samples divided by standard error. And the standard error is given right here. So let me write this out. This is going to be equal to, the statistic is going to be the 16.39 minus 17.10. That's the statistic. And then minus null is minus 0 in this case. So in the formula, on the sheet, I just skip that minus 0 because we assume the null is no difference in the means. And for the standard error, it's going to be the standard deviation, 5.05 squared, divided by sample size. So notice this is for the credit card. And then we look at the cash bills. That standard deviation was 2.47 squared, and that's divided by 51. All right, so if I throw this in the calculator, we get 16.39 minus 17.10. On the top, it's a negative 0.71. Again, this kind of reflects that there's not a very big difference between the sample means. And that's standard deviation, 5.05 squared divided by 106 plus 2.47 squared divided by 51. That gets us to about 0.6002. And I'm going to approximate these by taking minus 71 divided by that standard error. All right, and I get about minus 1.183. All right, so I have my test statistic. It's minus 1.13. Degrees of freedom is smaller. The two sample sizes minus 1. So in this case, it's going to be degrees of freedom is 50. Two sample sizes. I'm going to take the smaller one, subtract 1. And the p-value is, I'm going to go to Stacky, t-distribution, enter in the degrees of freedom, which was 50. Make sure I have it right, 50 degrees of freedom, minus 1.183. All right, this is a two-tail test. So I'm going to click two-tail. On the negative side, click minus 1.183. Click OK. And the two-tail is going to be adding up both of these probabilities, 0.121 plus 0.121. Or we could say right here it's going to be 2 times 0.121, which is equal to 0.242. All right, so looking at what we're doing, we've answered 1, 2, 3, 4, 5, state the test statistic and p-value, and then we reject or not reject. Here we're not given a significance level. Since we're not given a significance level alpha, we assume it to be 0.055%. Since the p-value is greater than significance level, .05, we do not reject the null hypothesis. Right, so there was a difference in the means of the two tip percentages, but it was not that great. The sample does not provide evidence that there is a mean, there's a difference. mean tip percentage between bills paid with credit card and with cash. So a very small difference in the sample, and that led to a do not reject. Not a very strong difference in the sample means likely there could be no difference in the actual mean tip percentage for all tips.